Hey, my name is Tyler DiBattima, and this is Lab Report 2. In this lab, we basically followed the same procedure as in Lab 1, but instead of looking at the charges as a point charge at the center of the tape, we looked at it as distributed charges along the tape. This impacted the way we can look at our overall electrical charge for the tape, as the charge would have to be greater to compensate for the electrical field overall decreasing. This is to make sure that our calculated electric force remains equal to our previously calculated gravitational force. And the electric field ends up having a smaller value simply because it now has x and y components, where we only consider the y components as all the x components end up canceling out. To fix this issue and come out with our new tape charge, we basically guess and checked with the calculations until we had the same force gravitationally as we did electrically. To begin tackling this problem, it was important to download the starter code presented to us and to trace through to see what the code entailed and what calculations we were needed to make. From looking through this, I was able to see the loop embedded within the heart of the code, which was calculating the net electric field in the positive y direction, and we would end up using this to calculate the electrical force in the same positive y direction. Through all this, and then using these values to guess and check with our charges, the charge on one of our tapes was found to be 2.26 e to the negative 8 coulombs, which was close to and greater than the value that we found in Lab 1. This is expected for reasons I'll mention and explain later on in this PowerPoint. Since this lab had a very heavy focus on computationally deriving the electrical force and the electrical charge on a piece of tape, I figured it was important to walk you through my code. So if you look on this page, you can see the physical constants, which include the measured distance and length that I got in Lab 1, as well as the function that I made for electrical field that I made in Lab 0. This function is very important for our code because it ends up calculating the electrical field impact on each specific particle and spot along the piece of tape that we define to look at this tape as a distributed charge rather than a centered charge. You can actually observe that very process on this slide, where you can see the function that creates the lines visually as a bunch of point charges distributed across a line, rather than one central point charge. It takes in the end that I define in lines 80 and 81 and creates that many points across a line to break up all the charges and give them each a specific charge that is equal to Q over N. Using these lines that we have now created and the properties of them, this loop actually calculates the electrical field and electrical force over and over again for each particle and sums it up to give us our final E field net and net electrical force in the positive y direction. As I mentioned before, this loop is the heart of our calculation because it does everything for us right here. Now that we've calculated all these values and that they're available to us, we can actually start creating the arrows and objects that represent them in our program. You can see the process here by the finding of the middle of the tape through the first line of code, and then the creation of two arrows that represent both the electrical force and the gravitational force in opposite directions. You can also see that the magnitude of electric force and gravitational force are both printed, which will be very helpful for us when we're trying to balance the two, when looking for our true charge. Finally, this slide shows the final product, what our code creates. And you can see that our electrical force and gravitational force are finally balanced now that we have guessed and checked and found our correct electrical charge of the tape. And you can see here that the green lines represent the electrical field impacts from the bottom blue tape on the red tape, as the white arrow represents the electrical force and the downward arrow represents the gravitational force. In conclusion, we have shown that it is possible to computationally calculate the electrical force, electrical charge, and gravitational force on a piece of tape. We have also proved that our expectations have come out to be true, as the overall charge of the tape did have to increase to compensate for the decrease in electrical field. And once again, this decrease was due to the electrical field being broken into x and y components, where only the y components end up contributing due to symmetry. If we had treated this tape as a point charge as we did in Lab 1, well, we would get a less accurate and smaller charge for our tape, because we would be looking at the tape unrealistically, as assuming that all the charges are in the center of the tape rather than spread amongst it. In the end, we can say that we have found a more accurate and more realistic way of calculating the electrical charge on a piece of tape. Thanks for watching.